I am
I am
Mo and
I am assigned
to discuss
as a report
about the experiment with
with more than two
groups and
and
action. So, here it is.
So we are going to discuss first what is experimental design. So when we say experimental design, it is refers to how participants are allocated to different conditions or independent variable in an experiment. Or it is the process of making decision about what type of experiment that you are going to run. There are two types of experimental design. They are the two-group design and multiple group design. So now let us find out what is two-group design and multiple group design. So when we see two-group design, it involves two levels of independent variable. One of them is nothing at all and other levels are variance. And it is the basic building block of multiple group design. While multiple group design, it has more than two levels of independent variable. Usually, one of the levels is nothing at all and the remaining are variants. For example, one is control group and three are more than experimental group. Two-group design and multiple group design are both valuable, but the difference between the two is the two-group design is tell you whether your independent variable has an effect, while multiple group design it tell you how much of an effect each level has. So the researcher must decide how or he or she will allocate their sample to their different experimental groups. For example of two-group design, an instant general marketing manager Anne is a fresh graduate of psychology student and became a newly hired personnel in a Vice Ganda cosmetics company, and her manager gave her a task to make an increase on sale of the lipstick product using two-group design. So the experiment involves only two variants. We have the commercial model and no commercial model in this experiment. We will see what is the most effective on increasing sales. It can be with a commercial model or without. So our goal of two-group design is to tell whether our independent variable has an effect at all. Multiple group design in experiment involves three or more variants. So for example, Louis is a marketing manager. He gave a task to Anne, who is a fresh graduate of psychology student and became a newly hired marketing personnel in Vice Ganda company of cosmetic. Her task is to make an increase on sale of the lipstick product. Anne wonders what kind of commercial model will she use to successfully accomplish the task. Anne decided to conduct an experiment to solve her problem. What kind of commercial model works best to make an increase to the lipstick product? She made a decision that the experiment design that she will use to solve her problem is called multiple group design. To make everything clear, she wants to know the kind of commercial works best to make an increase of the sale of lipstick product. She decided to use some people to be her commercial model. There are three persons as commercial model. One is celebrity, the other is veteran in endorsing the product, third is parental figure, and the other one is no person involved, just a product commercial. In their store, she gathers some customer who will be her experimental group. All are teenagers and make them listen to the celebrity, veteran, parental figure, endorse of the lipstick product and watch the commercial on TV, where the lipstick same in shade and brand. And she let the customer decide who is much better in endorsing the product and who among convinced them to buy the product. As Anne came to study her experiment, the whole picture is that her independent variable, which is endorser, our model has four levels: the non-model commercial, the celebrity, the veteran, and parental as endorser. While her dependent variable, which is the sale, have two levels. So this is if the customer will buy the product or will not.
Since we already done discussing about the experiment with more than two groups, so now we are going to proceed to interaction effects. So when we say interaction effects, it happens when one explanatory variable interacts with another explanatory variable and a response variable. So this is opposed to the main effect, which is the action of a single independent variable on the dependent variable. So for example, let's say we're studying the effects of a diet drink and a diet pill, which is our explanatory variable on weight loss. So our main effects would be the effect of a diet drink on weight loss and the effect of a diet pill on weight loss. So our interaction effect happens when the drink and pill taken at the same time. It's possible the combination could speed up weight loss or even slow it down. Synergy in medicine, where two drugs work together to produce an effect greater than their additive individual effects, is a special case of an interaction effect. So, the two or more variables that interact with each other to produce an interaction effect are called the interacting variables. So, if the variables don't act upon each other at all, then we say there is no statistical interaction, or that one explanatory variable's effect is constant across all levels of the other. We're going to proceed to finding statistical interactions. So if you suspect a statistical interaction exists, a factorial design can help you identify what the interaction effects are. So this is an example of factorial design. So in a factorial design, you run every possible combination of levels. So our levels of independent variable would be the diet drink and the diet pill. So our goal here is to weight loss after 1 week. So our interaction effect exists between the drink and pill, so resulting in increased weight loss when taken together. So this simple image shows that you would need for variation on treatment in order to fully investigate interactions. Here they are. So first is both diet pill and drink at the same time, only the diet pill, or only the diet drink, and neither the drink nor the pill, or which is our control group.
And more about interaction effects, so let's have another way. So again, when we say interaction effects, it occurs when the effect of one variable depends on the value of another variable. Interaction effects are common in regression models, ANOVA, and designed experiments. In this lesson, I will explain interaction effects, the interaction effect test, how to interpret interaction models, and describe the problems you can face if you don't include them in your model. In any study, whether it's a test, or manufacturing process, many variables can affect the outcome. Changing these variables can affect the outcome directly. For instance, changing the food condiment in a test can affect the overall enjoyment. In this manner, analysts use models to assess the relationship between each independent variable and the dependent variable. In this kind of an effect, this is what we called main effects. So while our main effects are relatively straightforward, it can be mistaken to assess only main effects. In more complex study areas, the independent variables interact with each other. Interaction effects indicate that a third variable influences the relationship between an independent and dependent variable. In this situation, statisticians say that these variables interact because the relationship between an independent and dependent variable changes depending on the value of a third variable. This type of effects makes the model more complex, but if the real world behaves this way, it's critical to incorporate it in your model. For example, the relationship between condiments and enjoyment probably depends on the type of a food, as we can say in this lesson. So, for example of interaction effects with categorical independent variables, I think of an interaction effects as an it depends effect. You'll see why. Let's start with an intuitive example to help you understand these effects in an interaction model conceptually. So this is our example. So imagine that we are conducting a test to determine which food condiment produces the highest enjoyment. We'll perform a two-way ANOVA where our dependent variable is enjoyment. Our two independent variables are both categorical variables. So these are the food and condiment. Our ANOVA model with the interaction term is satisfaction equals to food condiment and food times condiment. To keep things simple, we'll include only two foods. So these are the ice cream and hot dogs. And the two condiments are chocolate sauce and mustard in our analysis. So this is a hot dog with mustard to illustrate interaction effects. Given the specifics of the example, an interaction effect would not be surprising. If someone asks you, do you prefer ketchup or chocolate sauce on your food? Undoubtedly, you will respond, it depends on the type of food. That's the it depends nature of an interaction effect. You cannot answer the question without knowing more information about the other variable in the interaction term, which is the type of food in our example. That's the concept. Now, I will show you how to include an interaction term in your model and how to interpret the result. So how are we going to interpret interaction effects? So this is an ice cream with chocolate sauce to illustrate interaction effects. So let's perform our analysis. All statistical software allow you to add interaction terms in a model. Download the CSV data file to try it yourself. So that is interactions categorical. So we can use the p-value for an interaction term to test its significance. In the output below, the circled p-value tells us that the interaction effect test between the food and condiment is statistically significant. Consequently, we know that the satisfaction you derive from the condiment depends on the type of food. So this is our sample output. So this is how are we going to interpret. So in our factor information, in factor, these are the food and condiment. So the type, they are both fixed. Levels, they are both in 2. Values, so in food, these are hot dog and ice cream. In condiment, these are chocolate sauce and mustard. So now we are going to proceed to analysis of variance. In our source are food, condiment, and food and condiment. And we have degree of freedom, adjusted sums of scores, adjusted means of score, F value, and P value. So in our food, the degree of freedom is 1. Adjusted sums of score is 1.6. Same with adjusted means of score. F value, that is 0.06. P value, that is 8.801. In our condiment, the degree of freedom is 1. Our adjusted sums of score is 277.5, same with the adjusted means of score. Our F value is 11.07. Our P value 0.001. And then the relationship between the food and condiment, our degree of freedom is 1. Adjusted sums of score is 15,695.8. Same with adjusted means of score. Our F value is 626.5, 15. Our P value is 0.000. And then the error of degree of freedom is 76. Adjusted sum of score is 1905.1. In our adjusted means of score is 25.1. So the total of degree of freedom is 79. The total of adjusted sums of score is 17,880.0. So now we are going to proceed to coefficients. So we have the term. So our term are constant. In food, that is hot dog, and condiment, that is chocolate sauce. And our relationship between the food and condiment, these are the hot dog and chocolate sauce. So in our constant, the coefficient is 77.320. Our standard error of coefficient is 0.560. Our T value is 138.13. Our P value, that is 0.00. And then we don't have variance of inflation factor. In our food, which is hot dog, the coefficient is 0.141. In standard error of coefficient is 0.560. The T value is 0.25. The P value is 0.801. And then our variance of inflation factor is 1.00. Our condiment, which is chocolate sauce, our coefficient is 1.863. Our standard error coefficient is 0.560. Our T value is 3.33. Our P value is 0.001. Our variance of inflation factor is 1.00. And then in the relationship between food and condiment, which are the hot dog and chocolate sauce, our coefficient is negative 14.007. Our standard error coefficient is 0.560. Our T value is negative 25.02. Our P value is 0.000. And our variance of inflation factor is 1.00. So this is the statistical output that display an interaction effect that is statistically significant. But how do we interpret the interaction in a model and truly understand what the data are saying? The best way to understand these effects is with a special type of a line chart, that is what we call an interaction plot. This type of plot displays the fitted values of the dependent variable on the y-axis, while the x-axis shows the values of the first independent variable. Meanwhile, the various lines represent values of the second independent variable. On an interaction plot, parallel lines indicate that there is no interaction effect, while different slopes suggest that one might be present. So below is the plot for relationship between food and condiment. So this is our sample. graph for interaction plot for enjoyment, or that is our fitted means. So our x-axis here, so that are hot dog and ice cream, so which is represent for our food, and then our y-axis represents the value, so which is our mean of enjoyment, and then the line here and the color represent to our condiment. The blue is represent to chocolate sauce, and the red is represent to mustard. So the crossed lines on the graph suggest that there is an interaction effect. So this one, since they are interact to each other, which the significant p-value for the food and condiment term confirms. The graph shows that enjoyment levels are higher for chocolate sauce when the food is ice cream. Conversely, satisfaction levels are higher for mustard when the food is hot dog. If you put mustard on ice cream or chocolate sauce on hot dogs, you won't be happy. So, now we are going to proceed to important consideration for interaction effects. While the plots help you interpret the interaction effects, use a hypothesis test to determine whether the effect is statistically significant. Plots can display non-parallel lines that represent random sampling error rather than an actual effect. P-values and tests help you sort out the real effects from the noise. The example in this lesson are two-way interaction because there are two independent variables in each term, so which is the relationship between food and condiment. It's equally valid to interpret these effects in two ways. For example, the relationship between satisfaction and condiment depends on food, and then satisfaction and food depends on condiment. You can have higher order interactions. So for example, a three-way interaction have three variables in the term, such as the relationship between food, condiment, and X. In this case, the relationship between satisfaction and condiment depends on both food and the X. However, this type of effect is challenging to interpret. In practice, analysts use them infrequently. However, in some models, they might be necessary to provide an adequate fit. Finally, when an interaction effect test is statistically significant, do not attempt to interpret the main effects without considering the interaction effects. As this example shows, you will draw the wrong conclusions. So that's all for about the interaction effects. Now let's find out if you really understand about our topics, which are the experiment with more than two group and interaction effects. So everybody get a ball pen and paper, and you are going to answer these following questions, and then you are only given 1 minute each question, and then you are going to write only the correct letter of your answer. So here is the first question. Marty decides to design his experiment so that he has two groups that he will compare. Which type of experimental design is Marty using? Letter A, two-group design. Letter B, valid design. Letter C, pair design. And letter D, multiple group design. So, what will be our answer? Okay. Sir, for question number 1, that is two-group design, because Marty ran his experiment composed of two groups only. So next question is, so this is our number 2. Miriam wants to study how the temperature of the room affects productivity. She decides to run an experiment in which she will observe how many tasks her subject complete in rooms that are 60 degrees, 70 degrees, and 80 degrees. Why is Miriam's study a multiple group design? Letter A. Miriam's independent variable, which is temperature, has more than 2 levels. Letter B. Miriam's independent variable, which is productivity, has more than 2 levels. Or letter C. Miriam's study has more than 2 variables. And letter D. Miriam's study is different than all other studies on the same topic. So, what will be your answer? Okay, so let's find out. So, letter C. Miriam's study has more than 2 variables. Okay, next question is, Hank is trying to decide what type of experiment to run. Which of the following best describes what Hank is doing? Letter A, through group design. Letter B, valid design. Letter C, experimental design. And letter D, multiple group design. So what will be your answer? Okay, let's see if we have the same answer. The answer is experimental design. So next question is, that is our number 4. Sarah performs an experiment to determine the best amount of sun and water for a certain type of plant. She varies the amount of water the plants get each day and also much time they are in sun. At the end of 6 days, she measures how tall each plant is. What is the independent variable in this experiment? Letter A, the amount of sun. Letter B, the amount of water. Letter C, the height of the plants. And letter D, both the amount of sun and water are independent variables. So what will be your answer? Okay, so let's find out if we have the same answer. So, okay, that is letter D. Both the amount of sun and water are independent variables. Okay, now we are going to proceed to our last question. So that is number 5. Next question is, which of the following would be the best teacher-student interaction for dealing with the student on their cell phone during class? Letter A, speaking to the student privately to find out why they are using their phone so much. Or letter B, calling the students out in the middle of class. Or letter C, snatching the student's phone away from them. Or letter D, issuing a detention to be completed at a later time. Okay, what will be your answer? Okay, let's find out if we have the same answer. So, the letter A. So, we are going to speak to the student privately and find out why they are using their phones so much. Okay, and for your assignment short reflection where you can describe a hypothetical research study that could benefit from a multiple group design and explain the potential interaction effects they might be expect. And you are going to send your assignment through Google Classroom in the assignment folder. So that's the end of my report. Thank you for listening. Bye bye.